In this lesson, we're going to talk about special right triangles. And there are two special right triangles. The first one we're going to talk about is isosceles right triangles. For an isosceles right triangle, the two legs have the same length. So here is an isosceles right triangle. The little mark on the edge length tells me that those two legs are the same. You may also be aware that the angle of the two non-90 degree angles are actually 45 degrees because the sum of the angles in a triangle is always 180, and in an isosceles triangle the base angles are congruent to each other. So this is also known as a 45-45-90 triangle. In an isosceles right triangle, the legs have the same length, so I'm going to just call the legs A and the hypotenuse C. Pythagorean theorem says a squared plus b squared equals c squared. For this triangle, that's a squared plus a squared equals c squared, which means 2a squareds equals c squared, and solving for c equals a square roots of 2. So the ratio of the edge lengths is 1 to square root of 1 to 1 to square root of 2. And the most important thing to remember is that this is true for any isosceles right triangle. All isosceles right triangles are similar to each other. So, if you can remember, for an isosceles right triangle, the ratio is 1 to 1 to square root of 2. So let's do an example. Find the hypotenuse length in an isosceles right triangle where the edge length is 5. Again, you don't have to draw your right triangle, but here we go. The length of each leg is 5. We're going to call the length of the hypotenuse C. We know for this special triangle that C equals A times the square root of 2. And so C must be 5 square roots of 2. So if we've memorized the ratio of the edge lengths for the isosceles right triangle, we have less work to do than having to use the Pythagorean theorem. But we can always do the extra steps of the Pythagorean theorem if we're not sure we memorized the ratios correctly. So the second special triangle that we're going to look at is a 30, 60, 90 triangle. And the numbers 30, 60, 90 are referring to the measure of the angles, the size of our angles. So we have a 30 degree angle and a 60 degree angle and a 90 degree angle. We're going to call the short side, I'm going to go ahead and give you the ratio. The ratio of the edge lengths is 1 to the square root of 3 to 2. 1 is the shortest side, 2 is the longest side. So if the shortest leg length is A, then I know that B equals A times the square root of 3, and C equals 2 times A. Again, memorizing the ratio of the edge lengths is a great way to kind of save time when working through problems, but maybe memorization isn't something that we feel very comfortable with. So one way that we can work out the lengths of the hypotenuse and the shortest side and the side opposite 60 degrees is to draw another 30, 60, 90 triangle on the side that's opposite 60 degrees. And when I do that, I create an equilateral triangle. And in an equilateral triangle, all three sides have the same length. And notice that my shortest side would be A, which means the hypotenuse has to be 2A because it's the same length as an A plus an A. So let's use the 30, 60, 90 triangle edge length ratios to work through a problem. Find the unknown edge lengths in the 30, 60, 90 triangle. And I'm going to say that the side opposite 60 degrees is equal to 4. So the shortest side is going to be A, and the hypotenuse is C. The ratio of edge lengths in a 30, 60, 90 triangle is 1 to the square root of 3 to 2. So if A is the shortest side, then 4 equals A times the square root of 3, or the side opposite 60 degrees is equal to A times the square root of 3. So 4 equals A times the square root of 3, which means A equals 4 divided by the square root of 3. And you may be uncomfortable with leaving a square root or a radical in the denominator, but there is no problems. That's the number, 4 divided by the square root of 3. But if you really want to rationalize the denominator, A equals 4 square roots of 3 divided by 3. You can also say that. They are equal to each other. So then what is the length of the hypotenuse? Well, the length of the hypotenuse is twice the shortest side, and so C equals 8 over the square root of 3, or if you want to rationalize your denominator, 8 square roots of 3 over 3. And those are the special right triangles. We have the isosceles right triangle, and the ratio of the edge lengths is 1 to 1 to the square root of 2. And the 30, 60, 90 triangle (30 degrees, 60 degrees). The ratio of the lengths is 1 to the square root of 3 to 2.